Hello everyone, this is Mohammed Yaqub again, and this is another video on the STM Nucleo tutorial series. And in this video, I want to show you how to use ADC in continuous conversion mode, where ADC will continuously acquire and convert data, non-stopping, unlike the single conversion where we trigger it on if we want to get a conversion and it will go to sleep. But in here, the ADC will continuously convert data and send them to memory. With this mode, it's a good idea to use a timer trigger for the ADC so that the ADC doesn't go as fast as it can, which can cause a problem when using RTOS or kernel. And it's also a good idea, well, you have to use DMA to transfer data to memory if you have multiple channels, because the ADC has got only a single output data register, and you would have to use DMA if you have multiple channels so that you can transfer data to memory automatically. If you didn't quite get what I mean when I talk about timer and DMA, don't worry much, I'll bring it up again when I get to CubeMX. So in my demo today, I'm going to be using this thumb joystick again, similar to the one I use in single ADC mode. And I have two channels, the X and Y potentiometers, and I'll be using the ADC in continuous mode. So let's make a start and open CubeMX to set up a new project. On CubeMX, the first thing we need to do is click on New Project. And we need to select the right board, so go to Board Selector. It's the Nucleo 64 pins, F4, as the F401RE. This is the pinout by default, so let me first clear all the pinouts. So go to Pinout and Clear Pins. Yes. First thing I want to do is just enable my LED on PA5. And enable the push button on PC13 as digital input. Now, as I said, I've got my thumb joystick as analog input, and it has got two analogs, so I need to enable two channels on my ADC. I'll enable channel 0 and channel 1, which you would need to connect on PA0 and PA1. And the pinout, the STM pinout is, so looking at this module, you'll see you can either connect it to the Arduino pin PA0 and A1, or connect it to the adjacent one on the STM connector. So this one will be PA0 and this one will be PA1. I hope you can see this clearly. So we enable them. Let's go to configuration and configure the ADC. First thing, for the resolution, I'll just leave it as 12 bits, and then right alignment, scan conversion. So we need to enable the scan conversion mode because we have multiple channels and we want the ADC to automatically swap between the channels. And this is the what scan mode is for. So enable scan mode, continuous conversion mode to enable, no, disable now, because we want to use ADC continuously, but not as fast as it can. So we will leave this disabled, but we will use timer trigger instead. So let me enable a timer, I just forget to enable that. So back to the pinout, I'll enable one of the timers, possibly timer 2. Just set the clock source to internal and it will be enabled. And then you go to configuration back, click on timer 2, and these are the settings for it. So we need to set a prescaler and a period to adjust the speed of it. So I need to see what the frequency it's running at the moment. So I'll get back to the clock configuration. Clock configuration says that the clocks are running at 84 megahertz. So I need to set the prescaler and period accordingly. I'm going to bring it down to 100 hertz. So 84, this will bring it to 1 megahertz. 2 zeros and 1 zero here. It will be 1 kilohertz. Another 0 is 100 hertz. Just pause the video here if you didn't get what I mean. So all we do is we multiply prescaler and period and divide them by the clock frequency by it. So 84 megahertz divided by 8400 and then divided by 100, you will get 100 hertz. Now the trigger event selection needs to be set as update event, so this one will continuously trigger for the ADC, and click OK. And now back to our ADC settings. So I know I said we disable continuous conversion mode. This is for a reason. Because if we enable the continuous conversion, it will not care about timer trigger. It will continuously convert data as fast as it can. And this is not exactly what we want, because this is a dangerous mode. You don't use it often. So we'll leave this one disabled. And end of conversion is at the end of all of conversion, not just a single channel. And then external trigger, this is the one you need to select. So I want to trigger it by timer to trigger output event, just like what we enabled. And on the rising edge, number of conversions, we have 2 channels, so I'm going to do 2 conversions, and you will see you've got 2 ranks. Rank 1 is the channel that will be converted first, which is channel 0. Sampling cycles, I'll make this 15 cycles because this one requires 15 cycles for the full span. And then rank 2 is the channel that will be converted second, should be channel 1, 15 cycles again. And as I said, we need to enable timer to trigger the ADC frequently, and we also need to use DMA to take data to memory. So I'm first gonna enable DMA continuous request, which means DMA will be able to transfer data continuously from ADC to memory as soon as we get a timer trigger. Now I need to go to DMA settings to enable a DMA. DMA stands for direct memory access, so this will take the converted data straight from the ADC output data register and take them to a memory in the RAM. We will write the code for it when we get to Keil, but for now we need to enable it in here. So click on add, select ADC1, of course, that's the only option we have now, and the data width to word, so an entire word, 32-bit, the mode to circular, which means it will when it transfers the 2 data, it will increment the memory, and then when it finishes the 2 of them, we'll get back again to the first memory position. But if we kept it normal, it will keep incrementing the memory, which is not what we want here. So circular, increment memory, data width to word, that's all we need, I believe. So I'm also going to enable the ADC global interrupt, so at the end of every conversion, every sequence of conversion, as we selected here, the ADC will interrupt, and we can do something like blink an LED or read the data, and so on. Okay, so that's all for the ADC settings. So now let's click OK. And we're actually ready to generate the code. So click on generate source code icon. Select a location to store your project location in. Give the project a name. I'm going to call it ADC continuous timer video. Might be a long name. Select the IDE MDK RMv5 and click OK. And of course, once the source code is generated, click on Open Project, and this will take you to Keil Microvision IDE. And on Keil Microvision, we need to expand this project folder, application user, and open the main. And on our main, I'm first going to enable some variable, an array to store the ADC values. So unsigned integer 32 ADC value. It's an array of 2 elements because we have 2 channels. And then we need to start the timer. To start the timer, we need to start the timer first before we start the ADC, because it's the timer that's going to trigger the ADC. Hull TIM base start, I believe, yeah. And this one takes only a single parameter, the timer handle type diff, so it's TIM2 for timers too. It's defined by CubeMX at the top here, given the name HTIM2. And then we need to start the ADC as DMA. We use a function called hull ADC start as DMA. And this one takes the first parameter, the ADC handle type diff, so HADC1, and then a pointer to the array in which we want to store the ADC values. And I want to store them at this array, so I need to pass the array pointer, which is just the name of the array, and then the size, so 2 data points, and that's it. So this one will start the timer, this will start the ADC as DMA, and this one will get the data at the timer rate. The next thing I need to do is to define the ADC conversion complete callback, as I said, because I enabled the ADC interrupt, and I just want to toggle an LED in there. So to define the ADC conversion complete callback, go to functions and go to ADC, expand this, and you should be able to see conversion callback, this one. This one is defined as weak in the library, so I need to copy it over to my main, but without the weak object. So, and I can put my code inside it. So I'm going to copy it and put it here on bigger number 4, where user begin functions should be in there. Okay, and I just want to toggle my LED in here. And my LED is on port A, pin 5, so T-by-O toggle pin, port A, and pin number 5. And that should be it. So let's compile the code. Okay, perfect, compiled without any errors. Now I'm going to load it to the board, and we're going to have a look at both the LED on the board and on debugging mode. The LED to see the conversion rate, we expect 100 Hz, and then debugging mode to read the values. Actually, there's a little thing I want to change. I want to change the timer frequency, because you can barely see the LED blinking. It's too fast. So I'm going to bring it down to 10 Hz, which should be quite observable, and load it to the board again. Okay, good. We can see the LED blinking. Now let's go to debugging mode and read the ADC values. First thing we need to do here is to add the ADC array to the watch memory. So right click on this, add to watch 1. I should be able to see it in here. I'm going to expand it, remove the hex display, and expand the array. Now let me start the code. Okay, good. I can see them positioned in the middle bit, so I know 12-bit resolution is 4096, and this one is 2000, which means it's in the middle. Now let me move my X or Y axis and see how it changes. Okay, good. So it goes down to 0, and it goes maximum around 4096, which is good. And now my Y axis, same thing, goes down to 0 and up to 4096. Perfect. So this is working great. Okay, very well. That's all I want to show you today. Thanks for watching, and as always, if you like this video and want to see more videos like this in future, don't forget to like and subscribe. Have a nice day, and I'll see you next time.